Hello everyone. Today we're going to be talking about displacement and distance. And to do this, we're going to consider two different videos that were taken just outside Masters Hall. In this first video, we have Dr. Andreessen running across the football field. Alright, to better describe what's the motion that we see, we're going to annotate this video. Alright, so here we have at 2.7 seconds, Dr. Andreessen crosses this line right here. Alright, so at 2.7 seconds we have Dr. Andreessen crossing this line right here. And we're going to call that position x equals 0. And now we need to say which units that we're going to be using. We're going to be using meters. The football field is actually measured in yards. Each of these lines is 5 yards apart. But a yard is about a meter. This is good enough for our measurements anyway. So at t equals 2.7 seconds, Dr. Andreessen is at x equals 0. So let's take another measurement. Alright, so here at about 3.4 seconds, he crosses this line. And so we're just going to record that right here. So here his position is at x equals 5 meters. We're going to take just one more measurement. Alright, so here at 4 seconds, his position is now at x equals 10 meters. So here we have 3 different measurements. We took at 3 different times, and his position was at 3 different places. So we're going to now plot this on a graph. Which you can see down here. So here at 2.2 seconds, his position was at x equals 0. And at some later time, about 4 seconds, his position was at x equals 10. So going back to the video, we have Dr. Andreessen over here at t equals 2, and then some later time t equals 4. His position is now at this x equals 10. And what we have here is that over this time, these 2 seconds, his displacement, which we're going to call x, and we're going to draw this vector symbol on the top of it. It's like an arrow with just one side on it. X equals 10 meters. So his displacement over these 2 seconds was 10 meters. And we show this by a line. Alright, so let's consider one more video. Alright, so that was myself running across the same football field, and there's quite a different story there. So let's take a few measurements to better describe the motion that we see. Alright, so here at t equal 2.3 seconds, my position was at x equals 0 meters. And sometime later, t equal 4.5 seconds. My position is now at Since each of these are about 5 meters apart, I'm about halfway in between these two. So let's just call that 7 meters. That's close enough. 7 meters. And I'm still there between this 4.5 seconds all the way up until this 7.4 seconds. My position is still at x equals 7 meters. And I cross this 10 meter mark at t equals 8.5 seconds. So here we have our measurements, each taken at a different time. We have my position during each of these. And we see over these about 6 seconds, we see that my displacement is still this 10 meters. Alright, so let's plot this motion. Down here you'll see, in this graph, you'll see my motion is quite a bit different than Dr. Andreessen. So here between t equals 2 and 4, I moved the 7 meters, but then now there's some period of time which this x position is not changing with time. So here is my pausing or resting. And we note this by the fact that this slope is horizontal. And then later on, here at t equals 7, the motion continues. I start running again, and I cross the finish line here at this 8.5 second mark. So let's put all these together. So here we have 3 different graphs. We have Dr. Andreessen's position versus time. We have my position versus time. And I'm going to put up, just for better contrast, a fictional Mr. Orange and his position versus time. So, displacement we're going to define as x. And it's going to be defined as final minus initial. So when we're talking about this displacement, we need to talk about it over some time interval. So Dr. Andreessen's displacement, let's just say between t equal 2 and 4, his displacement, he was at 10 meters, his final position, and then his initial position was at 0. So this is the 10 meters displacement that Dr. Andreessen did. You can see that my graph tells a bit of a different story. So here we have my displacement over this 8.5 seconds. It's still going to be the same story. Here we have my final position at 8.5 seconds is still at 10. So we're going to label this as XP. It's going to be this 10 meters minus 0 meters. And we're still going to get 10 meters displacement that I had. But this took me a bit longer. It took me 6.5 seconds. So let's now just consider, for one more example, my displacement over these 7 up until t equals 7. So here we have XP is going to be, my position is at 7 meters, and then minus the initial position, which is 0. And so my displacement over this period of time between t equals 7 and t equals 2 was this 7 meters. Alright, so to contrast this a little bit better, we're going to look at Mr. Orange here, who instead of just resting here during this time interval, he's actually moving backwards. So Mr. Orange, between t equals 7 and 0, his displacement is going to be 2 meters minus 0 meters is going to be 2 meters is his displacement. So here we have motion of Dr. Andreessen here at t equals 2 to t equals 4. His displacement was 10 meters. Me, on the other hand, from t equal 2 up until t equal 4, I moved these 7 meters, and then I remained stationary for some period of time, and then I picked back up again up until 10 meters at t equals this 8.5 seconds. Alright, so Mr. Orange here at t equal 2, he continues on like I did up until t equal 4. But instead of resting here for these 3 seconds, Mr. Orange actually traveled backward to x equals 2 meters. And he was there at t equals 7, and then he continued on and made it to this 10 meter mark at t equals 8.5. So here we have a couple different ways of representing the same information, the same motion. Here's Mr. Orange. He went forward, and then went backward, and then went forward again. So what we're going to do is describe the total distance that was traveled during this time period. So this distance we're going to say is d, a subscript p for myself, and we're going to look at it summing along each of these segments. So between t equal 2 and 4, I went these 7 meters, and then we're going to sum up 0 because I'm not traveling during this time period, and then another 3 meters between t equals 7 and 8.5. So my total distance traveled was this 10 meters. So Mr. Orange traveled these same 7 meters that I did, but instead of pausing, he's traveling backward. But that's still distance that he's covering. So he actually covers 5 meters. You can see this is x equals 7, and this is 2. And then he's going to travel another 8 meters in order to make it to this 10 meter mark right here. And so when we sum up all the distances that Mr. Orange traveled, that is 15 meters. So the distance that Mr. Orange traveled was this 15 meters, but his displacement over this time period, this x, is only 10 meters. Because displacement only cares about final minus initial. It's not too worried about what goes on in between. So just to recap, we talked about displacement and distance. Displacement we represented by x with this vector on the top. And this is defined as the final minus the initial. This displacement has a magnitude, which is the length, it's the distance that is covered here, but it also has a direction. In the case of my motion, all of my motion was positive, but in Mr. Orange, you can see that he traveled in the plus x direction, then he traveled in this minus x direction, and then he traveled again in this plus x direction.